Good afternoon, everyone, and thank you for joining us today on our fifth RE Tech Talk. My name is Ankita Bokhar, your moderator for today's session, and I welcome you all to our fifth RE Tech Talk, where we will be talking about hybrid renewable energy technology, geothermal systems. This webinar is being organized as a part of collaboration between BEEP RE, a project on integration of renewable energy in buildings, implemented by IIEC and supported by the Swiss Agency for Development and Cooperation, and Solar Clean Energy Solutions. In this series, we have been exploring a variety of topics related to the implementation of renewable energy projects in buildings with our expert speakers. The talk series began on 17th February this year. However, if you were not able to attend, you can find the link of the recordings on your registered email. Please mark your calendars for these webinars. We will also be sending out reminders and updates to all the registered attendees. A quick recap on the last RE Tech Talk, where we looked into hybrid technology, solar and wind. Our speaker, Siddharth, explained the wind energy systems and the technicalities of the system. In today's talk, our expert will talk about the hybrid system of solar and geothermal. The talk will cover the background and technical specifications of the system. Our goal is to give you essential knowledge and information about RE technologies and application through our highly qualified speakers who are excited to be imparting it to you. Before I invite our speakers, I would like to run you through the GoToWebinar interface we are using for this webinar for our new participants. For the entire duration of the webinar, your microphones will be on mute and webcams will be turned off by default to avoid any accidental background disturbance. During the webinar, if you have any questions or comments, please share the same using questions or chat option available in the panel on the right side of your screen. The questions will be taken twice after each session. You can also access the additional informative material in the handout section. Please note that this webinar will be recorded and the recordings will be made available in the public domain. Thank you for your patience. Without holding you up any further, I will invite our first speaker, Mr. Anand Joshi, Project Manager, International Institute for Energy Conservation, for sharing the opening remarks and setting the context of today's talk. Anand has more than 8 years of experience and he has worked in the field of clean air, electric cars, renewable energy and energy efficiency. Anand, the mic is yours.
Thank you, Ankita, and good afternoon, everyone. I'll just give a quick introduction to our organization, International Institute for Energy Conservation. It's a non-governmental, not-for-profit organization established to foster the implementation of renewable energy and energy efficiency projects in developing countries and economies. We work on the agenda of sustainable development across various sectors to promote the energy efficiency and renewable energy. And we are working with the project called Integration of Renewable Energy in Buildings in India, which we acronymed as BEEP-RE project. And we are trying to implement the solutions for renewable energy in buildings at the design stage, how we can integrate these solutions in this project. And as a part of this project, we are hosting this webinar today. Actually, the webinar series where we are talking about various technologies one by one and how these technologies can benefit the building sector. And today's webinar, I'm excited to hear about the geothermal technology, how the application of geothermal technology can benefit the buildings, space heating and space cooling specifically, and how the solar energy systems can be integrated. So we'll learn in the later part that what are the processes around the integration of solar energy as well. So with this combination, we think that we'll be able to learn a lot about these new technologies, and I will not extend this introduction further because I know that the technical talks are very exciting. So thank you very much.
Thank you, Anand, for your insightful comments. Today, we are joined by Mr. Ishvinder Gill, the Geothermal and HVAC Consultant, to present today's talk. Mr. Ishvinder has over 10 years of experience in geothermal installation. He's a promoter of green energy systems and has installed geothermal systems all across India. While I share the controls of the presentation, I request everyone to write down their questions. All the questions will be taken up after this presentation. Mr. Ishvinder, the mic is yours.
Hi to everyone. Today I shall be talking on the topic of GeoExchange. So everyone over here, basically, everyone in their lifetime would have maybe gone to a hand pump, taken some water out of it, or experienced a bore well, you know. So the feeling over there is very enjoyable because during summers that the water coming out of the bore well or of the hand pump is cold, and during winters the same water is basically hot. So it is enjoyable by the normal public and all. So in this is what actually the GeoExchange is, that the groundwater or the ground temperature is at a specific level which is generally colder than the summer temperatures and hotter than the winter temperatures. So GeoExchange basically involves taking benefit of the thermal energy stored inside the earth. So here we are considering from our point of view, we are considering the upper layers of the earth, that is say up to the depth of around 600 feet. Now sun is the infinite source of thermal energy. So we use it in many ways. You have mostly seen the solar energy concept where we are creating energy from it. Now in geothermal and GeoExchange, we are basically storing the same sun's energy within the earth. And then that stored energy which is there in the earth, we basically are taking it out and using it to cool or heat some place. Now the sun thermal energy which is stored in the earth, we generally see that after a depth of 9 meters, the thermally stored energy becomes constant and it achieves a constant temperature. This temperature is generally the annual average temperature of the location. Like you are in Delhi, the average annual temperature would be somewhere around 26.5 degrees. So below 9 meters, you will find the temperature of 26.5 degrees. In Itanagar, the temperature is somewhere around 23.5 degrees. So when we excavate and go below, the Earth's temperature is somewhere around 23.5 to 24 degrees centigrades. So, but the upper layer, because over there it is either being impacted by the outside temperatures, so that will slightly warm up during the summers and it will slightly cool down during the winters. So we will say from the mean, it will slightly warm up during the summers, and from the mean, it will slightly cool down during the winters. We can take benefit of that, because there is a thermal lag within the earth or the temperature escaping out of it. This thermal lag is at times a month or 2 months. So we can use the summer heat in the winters or the winter coolness during the summers. So the initial months of the winters and the summers can be very beneficial in case we use the upper layers. And in case we are looking for a standard thing, then we can go below around 9 meters. Now, although this energy is stored in the earth, so how do we basically get the benefit of it? How do we harness it, harvest it? So this is based that in case you place any material within another thermally active body, now in this case the earth, we place any material, after a certain time the material will try to achieve the temperature or try to balance its temperature with the earth. So In case the material is, say, having a higher temperature than the temperature of the earth, then that material will get cooled down. And in case the material is, say, cooler than the average temperature of the earth in that zone, then the material will get heated up. So this is the base for our geo-exchange systems. Now, for the purpose of harvesting, we basically then create heat exchangers below ground. Now, these heat exchangers are basically pipes, so they can be of various materials, and we basically move water or air through it. This water or air will be basically taking some heat from a unit which is needs to be cooled down or heated up. So it basically that water flows through these pipes and it tries to average out with the temperature of the earth. So in case that water is at a higher temperature, it will cool down. In case that water is at a lower temperature, then it will heat up. So that is the basic function of the heat exchangers which we create in the geo-exchange system. Further, we shall now talk about the heat exchangers, how they are basically, we implement them at site, how they are made or what they look like, what the activities are involved in doing all that. So one of the heat exchangers is known as a U-loop. U-loop, as you can see in the photograph over here, is basically two pipes which are connected below to form a U. So the bottom of the pipe, we try to lower the whole pipe into a borewell. In the picture on the side, you will see there is a borewell in which this two pipes with the U at the bottom are lowered into the borewell. So these borewells we generally see, in case we are talking about daily, then we are going up to a depth of around 400 feet. So vis-a-vis the thermal level of the ground we have observed over here, and over the years, whatever experimentations and research we have done. So we have found in case we do it for around a depth of 400 feet, we can exchange heat with that pipe for around 0.9 TR of heat exchange can take place. Now these basically bore wells are done by the standard methodology of doing boring. And the pipes are then, once the depth is achieved, the pipes are lowered into it. And then the bore is grouted back. Grouted back means that we fill the bore back with the earth taken out, or a special grout, whichever is considered, that is filled into it. So the bore will not remain empty. With this grout, basically we bring in contact the pipe surface with the surrounding earth so that the pipe surface can then exchange heat. In the drawing on the side, we have basically shown that in case you have a residential building, say a 300 or 500 square yard, and you have some front lawn and rear lawn, then in this front and rear lawn, we can basically drill some bore wells and install these U pipes in them. It can be a single U pipe in it, or it can be a double U pipe in it. So in case we do a double U pipe in it, then they are connected in series or in parallel. Preferred is parallel. We have seen that in parallel connection, we get a better result. This is again the practical, when we do these, then how does the basically field is arranged in the location available. So we generally keep a spacing of 3 meters to 6 meters between each borehole in which the U pipe is being lowered. So in this photograph, you can see a number of U loops having been installed and the bores having been filled back. These pipes can then be taken underground to the location wherever we need to make a header or something, where they can be combined and connected to a HVAC unit ahead. So ultimately, once this is finished, the ground is usable for any other purpose. It can be parking or it can be a garden. So other purposes, it is not this that the land is then wasted, it cannot be used for anything else. The land can be used for other purposes. Another form of the same heat exchanger is that we make what is called a slinky. Slinky is basically coils which the pipe is laid in the form of coils which are overlapping each other. And one length of coil, like in case we say for around 1 TR of heat exchange, would be somewhere around 1200 feet to 1500 feet. And once the coil is made, its length will be somewhere around 100 feet. So once these coils are made, then we basically excavate the basically a deep trench. These trenches generally we keep around 6 to 10 feet depth, because the upper 3 feet is more impacted by the sun heat, and then the earth in itself basically becomes a insulation for the earth below it. So as we go deeper, the lower portions are less impacted by the uh, near exchange of the heat. So as we go deep, the impact would be, say, in days of the heat reaching over there. In case further we go deep, then it will take a month or 2 months for the heat to reach there. So that way the increase and decrease is not much. Over here we have shown, like this is the photograph for Itanagar. So where we have shown the ground temperature to be 23.7 degrees when we excavated the land to somewhere around 8 feet depth. Now these slinkies can be laid in various forms. In the previous we showed that the slinkies were laid right next to each other. It is preferable some distance is available between them, but in case it is not available, then there should be some land around them for diffusing the heat to the ground. So in case we are doing trenches, then there will be a gap between the trenches. It can be a difference of, say, 5 feet or 1.5 meters or more, depending upon the availability of the land around the building. So this is one form of the geo-exchange system. So these are known as horizontal slinkies because these are laid horizontally on the ground. The previous was known as vertical because those were U-tubes which were going deep into the ground and the borewell vertically. Once all these geo-exchange heat exchangers have been laid, then the pipes are all brought into the building or outside the building, where we create a place where a header is made. In the picture over here, you can see the pipes coming out from the ground, and these are connected for inlet and outlet points. Again, we provide some points where we can see the water travel through it and the flow rate of it. Again, in this header component, we also have a water circulation pump. This water circulation pump is basically again designed with respect to all the fittings, lengths, pipe dia, and as per the head calculated, the water pumps are provided. Over here, I would also like to mention that the pipes that are shown over here are basically high density polyethylene pipes. Generally, these are of pressure rating of 10. So, and these are having an OD of around 32 mm OD. So these are the kind of standard use, but we also use pipes of a higher or lower dia. Again, PEX is also used instead of high density polyethylene. So it is all dependent upon what the designer or the consultant or the person implementing is more, he can do it better, the application, whichever way. So again, we have found not very large variations in heat exchange due to variation in the pipe material. The variations are negligible with respect to the amount of heat that is being exchanged. From the header that is shown to you before. From here through the pump, we basically connect the whole system to a heat pump. So in this picture, we are showing a Samsung heat pump. This is one of the units we used at a project in Itanagar. So over there was a science center. So and this was the first time Samsung, in fact, brought in this unit into India. And after that, now they are now generally providing this unit. So this is DVMS water Geo. So Geo, this unit was basically for geothermal applications or for integration with geo exchange systems. So that is how the whole system becomes a geo exchange system. So basically we have the heat exchangers underground, then the header, and then our heat pump. Now these heat pumps basically have a reversible refrigerant cycle. So due to that, they can provide you heating during the winters and cooling during the summers. Further, these heat pumps are connected inside to the building to multi-split units. So they can be further connected through a refrigerant cycle or a water cycle. Mostly the units available now are generally the refrigerant based, but we can, where larger systems are to be done, where chillers are available. So chilled water indoor units can also be used with the whole system. The basic thing about doing all this is reducing the temperature at which we are exchanging the heat being thrown out by the heat pump. In case we are exchanging it at a higher temperature, which is the ambient air temperature outside, which is say 40, 45 or whatever, instead of that, in case the same heat is exchanged with say a temperature of 26 or 30 or 32, then the efficiency of the heat pump improves. The compressor has to work less to exchange the same amount of heat, which basically ultimately gives us saving in energy and also longer life of the equipment that we are using. During basically previously I talked to you about heat exchangers, which were basically closed loop. That is, in them we once fill the water, and the water basically keeps on circulating in the loop, and additional water is only added from the point of view in case any air had been trapped within the pipe, which initially we tend to try to remove all the air through it, but still in case something is left, so for that basically a connection is provided to provide the extra water. Otherwise, no extra water is required. So one of the major parts of this is also that we save water. Apart from saving on energy, we save water, and we are getting a higher efficiency system. Another way the heat exchange can be done is through an open loop. Open loop is basically you do a bore well and like a tube well, and you extract water out of it, and that water we basically pass through a heat exchanger, which then exchanges heat with again the heat pump unit. So in this slide you can see a picture. This project was done in for NTPC at their research center Netra in Greater Noida. So over here we have done two types of system, one closed loop and one open loop. The picture over here that you're seeing is of the open loop. So over there, over here in the header, we can see the heat pump behind Samsung heat pump. Then we can see a plate heat exchanger. The plate heat exchanger basically is provided to between the heat pump and the bore well, so that in case any sand or any other material is being pumped out from the bore well due to any reason, that is first basically removed by a sand filter which is provided, and after that when it passes through the plate heat exchanger, then it is recharged back to the ground. So the water is not wasted around, it is recharged back to the ground. So in the second picture, we can see a recharge bore which has been done. We have also done over here a recharge trench. So since the soil over here was sandy, and sandy soil basically absorbs water much faster than any other soil. So we found one bore to be sufficient to be absorbing it. But there can be other soils where instead of one bore, we might require 2 or 3 recharge bores to take and absorb the water. So that will all depend upon the geology at the location. But this is a more simpler way of doing it. Again, we are not wasting the water. We are recharging it back to the ground from where we took it out. So in both the cases, we are again from a bore well, we are getting the water at the temperature of the ground, which is again, say in a zone like Delhi, it is around 26 degrees Celsius. So which is better off than the ambient temperature of the air outside, which is say around 40, 45 during the peak summers. So again, the system will be working much better. Again, the outdoor unit is connected to multi-split units inside the building, which can again be a refrigerant cycle or a water cycle. In this case, it was a refrigerant cycle. Another thing that we looked into, because we have been associated for research work with various organizations. The previous was Netra. So in this case, we were doing a research for energy piles. That is basically wherever in a building the foundations are done in the form of a pile, whether we can use that to get the thermal energy also. So in this slide, you can see the photograph of basically the reinforcement which is to be lowered into the pile foundation. In that, we have placed geothermal U-loops. So these U-loops are basically lowered down into the piling during the after the bore well has been bored. So after this lowering, the pile is filled with concrete, and the pipes are again taken out and connected to a heat pump through the header and all that we have shown you in the previous slides. So although we haven't implemented a full major project of this, but we are doing it for IIT Delhi at the moment for research work at the moment over there. So basically, these are what we showed you are the means to be at least one step better than what in HVAC we already have. Although as consultants and architects, you would be very much aware that most of the energy is saved by designing first the building properly and in the best way possible. So major energy is saved over there. So then we see that what next can be done to save the energy. So next steps are basically these, that okay, we try to reduce the energy consumed by the air conditioning machine now. So the best way to reduce it is so that the machine interacts with the lower temperature outside or below the ground. That way its efficiency improves and we reduce the energy. And then thirdly comes your solar. So once we have reduced the energy requirement, then the solar requirement will be also less. The same way the requirement of transformers, the requirement of main switches and their parts and all. So ultimately, when you combine all these technologies, you are not only able to save your energy levels, but you're also able to save on materials and many other wiring and other aspects. So that is the basis for us going into the geo exchange technologies and all. I would like to thank you all for listening to me for this technology. And in case you have anything to ask about, you're free.
Thank you, Mr. Ishvinder. Now I would like to invite our speaker for the second session, Mr. Sandipan Das, Business Manager, U Solar. Sandeepan is a highly capable professional with proven track record of effective communication, interpersonal skills, logical thinking, and analytical acumen. Uh, we would be sharing the controls with you, Sandeepan, right now.
Thank you, everyone, for this lovely opportunity, and Ishvinder S for such a good presentation on geothermal. So I'm Sandipan Das. I'm representing you Solar Clean Energy Solutions. So I'll be covering a topic of how to choose or choosing the right vendor for your solar project. Before jumping onto the topic, I will just give a brief introduction about USolar. Yes, USolar is a engineering, procurement, and construction company headquartered in Bangalore. We incorporated in the year 2010 by Mr. K.R. Harinarayan. And with a decade of experience, we have installed around 170 plus megawatt of solar power plant across pan India with 250 plus project executed. We have in-house experience of our project team, operation and maintenance team, and we do project development at the CapEx OpEx model. We have done projects on the rooftop, ground mount. Being a engineering company and a technology-driven company, we have done project in building integrated power photovoltaics and also battery-based solutions. So jumping on the topic that how will you choose, why solar is important at present and why it is the talk of the town along with other renewable energy, but solar is much more faster adaptable in a country like India. Just giving you a background, India has a net zero target, to go net zero by 2070, and this is a very steep and very challenging target taken by our Prime Minister, Mr. Narendra Modi. And India has a target of going 450 gigawatt by 2030, which includes around 280 gigawatt of solar. But till 2023, we have only installed around 66.78 to be precise gigawatt. So in the next 7 years, the target of reaching of 280 is quite steep, but everyone is trying to contribute to that and trying to achieve that target. At present, standing in 2023, we have around 578 solar companies in India. So it is very important for the end consumer to select the right solar company who has technology experience, who has experience in the market, and who has worked with some of clients to build the solar power plant. Why it is important to select the right solar vendors or the technical expert? Because this is a one-time investment, an investment which will last maybe next 25 years or more than 25 years, like 30, 35 years. And in recent study shows in the foreign market that the solar panels will continue generate after 25 years also. So it's a one-time investment and it has to be maintained. It's like buying a car, which it has to be maintained on a periodic basis. And the car dealer should give you a very good post-service so that you have a very good experience throughout the journey. So there's a reason we have accumulated this topic of how to choose your vendors. What are the questions that you need to ask your vendors, or what are the evaluation parameters that you need to check? And I have done some studies, I've done some research, and with my experience in the industry, I've clubbed together certain questions and certain slides, and I will answer those questions so that you have a better view of how the technology can be adapted with the right vendor. And why choosing a right vendor? I'll tell you a real experience that I had like 2-3 weeks back. I was working in an office when a person entered in our office, and he was very nervous and he did not know what to do. So I approached him saying that, yes, sir, what's the problem? He said that before COVID, he has installed a 3 kilowatt system at his residence in Bangalore, and he's feeling that his solar is not generating up to the mark. So I asked him, it's very good that you're moving into sustainability, but so why are you coming to use solar? Because I don't think we have installed the plant for you. He's saying the actual problem is the vendor who has constructed the solar plant for him. The vendor has shut down his business post COVID. So COVID has affected his business and the vendor got shut down. Now he does not know whom to go, where to go, and how to solve his issues. So he had issues with his inverters, and then as we being in the market for the decade, we know some inverters manufacturers. We connected him with them, and his problem got resolved. But yes, right vendors has to be there, because over a period of decade, India is a very initial stage, or it's a very baby steps to a solar. It has not matured yet. The market is maturing, but it has not matured. So as it is maturing, many players are coming into play. There may be many top players, many middle level players, or many new players into the market. So that is the reason choosing a right vendor, knowing to know how to ask the right questions to your vendors, so that you have a clear idea at what you're investing. Your investment amount starts from a few lakhs to crores of rupees. So you should be aware of these answers before selecting the vendors. Yeah. So first, my topic is experience and professionalism of a vendor. So the first question when you approach a vendor, when you decide to build a solar power plant for your industry, for your commercial, for your residence, it's a very good step towards sustainability. But when you are approaching the right vendor, you should know the experience in the market he has. What are the projects that he has done in the market? If you can get some reference of the project, you can talk to the reference clients. But experience, is it a technology driven company, or is just a sales driven company just trying to sell you some plant? Because solar is not a commodity product that you go into the market, buy it, and come back home. It's a technology driven product. It's a technology driven service. So you might not be aware of the technology involved in the solar, but the vendor should have a very good knowledge about the technology. He or she or the vendor should have a very good in-house expertise to carry out the technology designing, because some roof can be challenging, some ground can be challenging to do solar. So if you want to go solar, the vendor should give you the right solutions. And the process. So in a normally what being with my experience and the process that is followed in a total life cycle of adopting solar is first the technical assessment. The vendor will ask for your locations, for your electricity bills. He will size the plant according to your technical assessment of the electricity bill and the location. Once that is assessed, he will submit a commercial. Once that commercial should include what are the key scope of matrix, what are the top A line items he has considered for the projects. Once that is done, the discussion is made, and you are pretty sure that yes, okay, this is a vendor that I have selected, I want to go solar. Once that movement happens, then it moves to the project team. There should be a dedicated project manager who will help you to execute the project for you. So whenever you have a questions regarding how is the process going, when will my net metering happen, when will my solar adoption gets complete, that dedicated project managers will help you to understand. He will do all the licensing and documentation process and submit it to the local government to get your approvals done. And ultimately, after a quite a span of time, your uh, your solar power plant will complete and will be handed over to you. So generally, with coming to the question of how long will the installation take, generally a solar installation takes maximum 3 to 4 months, depending upon the availability of products in the market. As I said, India is still growing in this market, so there are many module manufacturers, inverters, and other line items players who are playing in the market. But sometimes we also see that in the market there's a shortage of some cells, shortage of semiconductors, which delays the supply of the materials. Also, from post-COVID, we have understood that certain situations like COVID can also delay the procedure of supply and demand management. So, but technically and normally in a realistic situation, it takes 3 to 4 months to complete a project. Moving to system installation cost. So a solar power plant, we only sometimes when I have talked with my clients or I've talked to someone, they say that solar power plant is only like panels or inverters or structures. But you need to understand a solar power plant consists minimum of 18 to 25 line items. Yes, some are class A line items, which are very important, and some are class B and class C line items. But they require 18 to 25 of line items, which includes panels, structures, inverters, cables, earthing, plugs, and etc. But it's a 25 line items. So you need to understand when you're asking the vendors, he has submitted a quotation for your capacity. You need to ask him what are considered, because there will be certain times that there is a sheet roof and the safety for harnessing and walkways are not considered in the costing. Later they will come and say that, oh, well, we have not considered this for the safety. Please give us the additional cost. But that is not justifiable. So there should not be any mismatch between the vendor and the end consumer. The end consumer has the right to know that whatever price he's paying and what are the line items that he's paying the price for. Is he paying, is the permits and inspections or approvals for the local discom is included in the cost? Is the wiring till at what level is considering the wiring? What are the cable trays, cable trenches are laid, or is the wire just kept underground? Because that is a big safety issues that might happen and people might lose life. What are the warranties of the system? So technically speaking, the modules comes with a 10 years of product warranty with a 25 years of product guarantee, and inverters comes with 5 years warranty, and other structural and line items comes 1 to 2 years. But that warranties papers, that warranties document should be handed over to the end customer. The end customer should ask, okay, where are my warranty documents? Can you take it under my name? So it is a duty of the vendor to give those warranty documents while he's commissioning the plant and handing it over to you. Like the story like the real situation I said, tomorrow if the vendors go bankrupt or he's just changing his business, you do not have any documents to understand if a solar is running bad or is it running in a very good condition. Because if you go to the market, if you go to the manufacturer and say, boss, my inverter is not running good, he will first ask, what is your inverter's OEM number? What is the inverter products? What are the warranties that are there? How many years you have passed? So these documentations, being knowledgeable end customer, it is very important to collect it from your vendors. Proprietary equipment. So the first question is the equipment proprietary? Here, what I meant to say is the equipment coming from a very good brands? So, as I said, there are 576 solar companies, but there are more than 100 or 50 module manufacturers playing in the India, and more than 100 to hundreds in the world, the global. But there are very few tier 1 module manufacturers, tier 1 inverter manufacturers, tier 1 cables, so and structures. So you should know that whatever the procurement happening, especially for the A-class items like modules, inverters, structures, cables, are they of good tier 1 quality, or are you going to play with the quality or with the quantity? That depends upon obviously on the end consumer. But yes, if you're paying for a premium, if you're paying for a quality, it is your right to know that the vendor is providing you the A1 quality, what he promised during the proposals. Now coming to replacements, so as the market is developing, we see that many service centers of the modules are there, inverters are there. So technically in solar, it is not a replacement mechanism. So I'll give you an example, explain about this point. So what happens is in a solar system, for example, it's running for 10 years, and the 11th year, you feel that your modules is not working, a certain module is not working, or your inverters is not working. So that time, the inverter manufacturers or the service people, they want some data. They give the data. They have a replacement policy, because within the warranty they will surely replace. But after the warranty, they won't replace, but they might rectify the problem. So as I said, modules comes with a 10 years of product warranty. They do not expand. They do not extend their warranty. But inverters come with string inverters come with 5 years warranty, and with the scope of extending the warranty for further 10 or 15 years. And yes, can the equipment be repaired by any repair person? No, it is not required. It cannot be repaired by any repair person or anyone who just has a electrical knowledge. Because when the solar system is set up, it is set up through a certain stringing, certain way, and the person or the people who is doing the O&M service, they should only be appointed to repair the solar system, because they have all the drawings present. Unless until you have the blueprint of your system, you cannot repair the system. Options of expansions, I have seen very less options of expansions in the rooftop, because there's a limited space. But yes, if it's a ground mounted system and if you have acres of land which you want to go solar, you will have an option to expand in the future. That is always there. Local governments. This is also a very important point, because understanding the local laws or the local regulations regarding installation of solar in the states is very important. Why? Because our solar policy is not a centralized policy. Central has a policy, but it is the authority of the state to regulate the policy in their own way. The central policy is just a guideline for the state to implement the policies as their own. So different states will have different solar policy. Some states has a policy that till 85% of the sanction load or your contract demand, you can do solar. Some states has 80% and some states has 100%. I'll take an example. In Maharashtra, you can do 100% of your sanction load as solar, whereas in Karnataka, you can do 85% of the solar or 85% of your contract demand as solar. So as our policy is decentralized and it is governed and regulated by the state governments, it is very important for the vendor to know that state policy, or he should have good licensing partner for the state policy to take care of your commissioning of the solar power plant. Maintenance. This is another aspect of solar. As I said, your solar power plant is for 25 years of terms, and a good power plant when maintained, a solar power plant when maintained well, can give good generations over the years, and your return on investment can come a little faster. So in doing the maintenance, it is very important that a able or knowledgeable person does the maintenance, or he or the person is aware of how to maintain the solar power plant. Maintaining a solar power plant is not only just cleaning of the modules. So it's not like putting the water on the modules and the modules will get cleaned, but there should be a periodic check of the inverters, of the wiring, how the wiring has been done. Is there any fuse or short circuits or any wear and tear on the wire that has to be repaired on a periodically? Also, maintenance involves the so some vendors has in-house operation and maintenance team who will maintain the solar power plant for you, do remote monitoring and do analysis. So it is very important, EPC place like us to do maintenance of the solar power plant, because we have dedicated analyst who is analyzing every time of the solar power plant that has been installed by us, because as a part of a preventive maintenance, and in case there is a defect in the solar power plant, it is very easy for us to substantiate the manufacturing companies that with data that this has been the yield for the last 2-3 days. This has been the yield this month. There is a decline in the yield. Please have a check. Then they will work on the check. So maintaining of a solar power plant is same as you're maintaining a car. You're buying a car. You want to experience the goodness and drive of the car. But if you don't maintain the car well, your car will stop working after a certain time. Same way, please maintain your solar power plant or the vendors that you're selecting. He should have either outsource of his operation maintenance or in-house, but that should be a periodic 1 month cleaning is absolutely fine. For a solar power plant, a person comes from the office, sees your solar power plant, shut down the power plant for like half an hour, have a checklist of this will be the checklist of his maintenance. He will do preventive maintenance. He will check the panels, inverters, wiring, LT panels, and the small lugs, MC4 connectors. And while after doing so, when he completes his checklist of 10-20 items, he can confirm that the plant is maintained well and he can leave. It's just a 30 minutes work, but this ensures that your plant continuously generates more for the next 25 years of term. My next topic is structural capacity. This is very important in respect to rooftop solar because, as I said, in India, solar is much easily adaptable and one of the fastest adaptable renewable source of energy because it requires less capital investment and you can do it on your rooftop. So in that case, one should know, especially for sheet roof, it is very important to understand, does your sheet roof have the ability to hold the solar power system? So when I talk about this, so solar power system will come with solar panel structures. So these structures and some wiring, some cable trays, some railings, mid rails or its long rails. So this will come and will sit on your structure, on your sheet roof. So this sheet roof should have has the ability to minimum withhold the capacity of one single panels of 23 to 25 kg. So understand something, for a capacity of 100 kilowatt, where 1 kilowatt requires 25 kg, 100 kilowatt will require 2500 kg that will be sitting on your sheet roof, and your sheet roof should have the ability, and the structure of the building should have the ability to withhold that weight. Considering the structural capacity, it's not only about the weight, but also about the wind speed. So technically at the current situation, the structures can withhold around wind speed of 50 meters by second or 180 kilometers by hour. So that much of wind capacity, the structures have the ability to hold. So for example, so there are certain buildings which are very high rise, and the solar plant has to be installed on a 14th floor, 15th, or maybe on the 20th floor. So that time the wind speed is very high at that altitude. So it is very important that the structures are very well set up on those roofs, and the wind speed is taken under consideration while putting the solar power plant. Then comes the azimuth angle. Azimuth angle is an angle of the building. So it is the how much of deviation you are having from your true sun. So the sun angle is the sun from the sun radiation or the sun angle. So it's like north, south, east, west. So it's a true south is there. And for the sheet roof, there should be certain deviation because every building is not perfectly made. So that is the azimuth angle that has to be considered when setting up a sheet roof, solar power plants on the sheet roof, and the angle of tilt, which is also being considered when doing the, especially for RCC roof or a ground mount of solar system, where how much of tilting of the panels has been considered while setting up the solar power plant so that maximum yield can be generated. Technically speaking, your angle of tilt is basis of the latitude. Like for example, in Karnataka, the angle of tilt is 12 degree to 13 degree because that's the latitude. So while we move towards north, the latitude goes higher, so your azimuth will be much more higher. So these things has to be considered for structural analysis of the while before setting up of the solar power plant. So now moving to criteria for evaluation of vendors on the basis of OPEX model. So now we're talking general as well as CAPEX, where we're making the 100% of the investment, and we are set, or a vendor is setting up a solar power. But in an OPEX model, the vendor is investing 100% on your roof, generating the power for you, and you would using the solar power plant and paying the bills accordingly. So for that, there are certain criteria because he's investing. So you need to sign a PPA with him, and some legal documentation has to be done because it's for a long year terms. So while when doing on the OPEX model, you need to understand the economic benefit because as you're not investing, you're just only paying the amount of energy that is getting produced. So you need to understand the capacity that is being installed. Is it fully taking care of your load, or how much of the load is getting taken care by the capacity? What happens if there is an excess power? So as in India, there is a net metering system. Most of the states have that net metering facility, where if there is an excess power, it goes back to the grid, and the grid will rebate some amount from the amount of energy that you've given back to the grid. So that net metering system should be enabled if you feel that your load is much lesser than the solar capacity that is getting installed. So what happens if too little energy is produced? So in case of OPEX, there is always some clauses that are get mentioned on the legal document that I have installed this much of capacity and this is my guaranteed generation. So if there is a shortfall of the guaranteed generation, there should be some clauses where you pay me the penalty for not giving me the guaranteed generation. Because when a vendor is coming into an OPEX model, he is committing you certain amount of generation that has to be met every month or in a year, and that he has to take care of it. So if there is a shortfall, you can surely ask for the penalty from the vendor. So content of the proposal for the vendor. So when you are, when asking or a vendor is submitting a proposal to you, you can ask for the, when you share your bills and locations, he will make a capacity estimations or AutoCAD drawing of the solar power plant, how the power plant looks. You will have a fair idea of, okay, this is a solar power plant that will sit on my rooftop or in a ground mount or in the land that I've selected. What is the type of system? Is it a CAPEX, OPEX? Is it the system is with net metering or is it for a captive generation? So captive generation, right? You will use the full power without giving any excess back to the grid. What is the estimated generation from the system? So for 1 kilowatt system, how much of generation he's estimating that the solar power plant will produce? Initial BOM, we are understanding that this will be the line items that will get involved with the solar power plant. So initial BOM, which includes modules, structures, inverters, the cables, the earthing, lightning arresters, and the government licensing, and the cost involved for setting up the total turnkey of the solar power plant. What is the scope of work involved? So these things be very clarified, from the start. What is yours being a end consumer? What is your scope of work regarding setting up the solar power plant? And what is the vendor scope of work? So that after, during the project stage or after the project, you do not have a clash. Because we, as being in the industry for 3 years and working with U Solar and talking to other companies, main important thing between a vendor and the end consumer is the relationship that we build it together. So in both of us has to make sure that any point of time the relationship doesn't hamper, because this relationship will continue till the end of your solar power plant life. So it is very important. And you can ask for similar projects done by the vendor and what experience he has in the market, how many states he has worked for, what are the challenges he has faced. while working in that state or in that location. And if you can get any reference of that of the solar power plant he has installed, then it will be great for you. That's all from my side. Thank you for such a lovely opportunities. I'll be open to take questions.
Thank you, Sandipan. This brings us to the end of the talk. I would like to thank everyone who attended and participated in this talk. I would also like to take this opportunity to remind everyone that we have our last RE Tech Talk on the 5th of May, that is a Friday, at the same time, where we will be discussing waste to energy technologies of biomethanation. We hope to see you all next time. Thank you and have a great day.